A 10-card hand is dealt from a well-shuffled 52-card deck. Let the random variable x be the number of jacks in the hand. Find the probability mass function of x. So over here we're going to write the probability mass function. And in the last example we wrote the support separately, but now what we're going to do is we're going to write the support out here. And the question is, how many jacks can you get in a 10-card hand? Well, you can get no jacks, 1 jack, 2 jacks, 3 jacks. At most 4 is the number of jacks that you can get in a 10-card hand. So the next challenge is going to be finding f of x. And in this case, since the order that the cards are dealt is not an issue, we use combinations, and there are 52, choose 10 different hands that are out there consisting of 10 cards. Then for the numerator, we want to know how many of those 52, choose 10 different hands that can be dealt, how many of those contain exactly x jacks. So up top we say, out of the 4 jacks that are in the deck of cards, choose x of them for the hand, and that needs to be multiplied by, out of the 48 non-jacks that are out there, 10 minus x is the number that you want to choose. And again, order is not important. Notice that the 4 and the 48 add to 52, and the x and the 10 minus x add to 10. And you see that that pattern emerging often in problems of this type. Now, if we were being very careful, and we're not being very careful here, but if we were, we would also come down here and say 0 otherwise. But in the textbook and in these notes as well, I'm going to leave this 0 otherwise out. So we will write f of x in this fashion with support, and we'll just always assume 0 otherwise. Now on the next page, if you want to plot that probability mass function, this is again our code, and we set the vector x to 0 through 4. Those are the support values. Then we have 4 choose x times 48 choose 10 minus x up top, divided by 52 choose 10. This time we're using the choose function here rather than writing them out as factorials. And then we use this same plot command from the previous example. And here is the probability mass function of the number of jacks in a 10-card hand. Most of the time you're going to get no jacks or 1 jack, and then occasionally you'll get 2, 3, and then a tiny fraction of the time all 4 will show up in the hand.